Let us do more complex projects. So before we jump into the Vpro project, we're gonna look into the Docker Compose command and options overview. So this is the Docker Compose syntax, and these are all most widely used commands. We have discussed about the same. Starts with build, bundle, config, create, down, events, exec is the famous one, and most widely used one is Docker Compose up with detached mode and stop, start, and rm, run, pull, push, logs is also widely used. Kill images, Docker Compose images, and version just to cross to validate the installation of Docker Compose. We use this. Yes, now the complex and complicated exercise that we're gonna do is Wipro app development, because here we are gonna use 5 different services. We are gonna containerize this B profile application, which consists of 5 different services. This was made by DevOps engineers, so that other DevOps or MLOps guys, whoever wants to learn any application, so you can use that repository. So you can get this repository, type v profile in v profile GitHub, so you'll get it. You can get this repository directly from the GitHub itself. Okay, so Vpro app deployment we're gonna look. So with this we're gonna learn a lot of things. So even the complex how the complex projects can be dealt. So how the complex projects with consist of 5 services can be deployed, all the things with container, all those things can be seen here. So let's see the provisioning first. So in this project we have 6 services, but we use 5 services. Those are Nginx, RabbitMQ, Tomcat, Memcache, and Elasticsearch and MySQL. So Nginx is our web service, Tomcat is an application server, and RabbitMQ is a broker or querying agent, and Memcache DB caching, Elasticsearch indexing or search service, and MySQL is SQL database. So setup should be done in below mentioned order. So we'll begin with MySQL, that is database service, then Memcache, that is DB caching SVC, that's a DB caching database server, and RabbitMQ broker or QE service, then Tomcat application service, and Nginx, it's a web service. So now let's see the flow. Let's see the flow of Vpro architecture, Vpro web architecture. So it begins with a load balancer. You see that? A load balancer. Load balancer, load balancing refers to efficiently distributing network traffic across a group of backend servers, also known as a server farm or server pool. So normally this load balancer will be connected with the public network. So a load balancer acts as the traffic cop sitting in front of your servers and routing client requests across all servers, capable of fulfilling those requests in a manner that maximizes the speed and capacity utilization and ensures that no one server is overworked, so which could degrade performance. If a single server goes down, the load balancer redirects traffic to the remaining online servers. When a new server is added to the server group, the load balancer automatically starts to send requests to the new server. So next we have is Nginx. Nginx Plus and Nginx are the best in class load balancing solutions used by high traffic websites such as Dropbox, Netflix, and Jinga. More than 350 million websites worldwide rely on Nginx Plus and Nginx open source to deliver their content quickly, reliably, and securely. As a software based load balancer, Nginx Plus is much less expensive than hardware based solutions with similar capabilities. The comprehensive load balancing capabilities in Nginx Plus enable you to build a highly optimized application delivery network. When you insert Nginx Plus as a load balancer in front of your application and web server forms, it increases your website's efficiency, performance, and reliability. So Nginx Plus helps you maximize both customer satisfaction and return on your IT investments. So then what we have is our Apache Tomcat. So then we have is our Apache Tomcat. So Apache Tomcat, called the Tomcat for short, is a free open source it's a free open source implementations of the Jakarta servlet, Jakarta expression language, and WebSocket technologies. Tomcat provides a pure Java HTTP web server environment in which Java code can run. Tomcat server receives a request from a client through one of its connections or connectors. If it has not, Tomcat compiles the servlet into Java bytecode, which is executable by the JVM, that is Java Virtual Machine, and creates an instance of the servlet. Tomcat initializes the servlet by calling its init method. So Tomcat is a web server and web container. In one, some may call it an application server, but it's definitely not an full-fledged Java EE application server. So key difference between a Tomcat and Apache HTTP server. The Apache HTTP server, but the fundamental difference is that Tomcat provides a dynamic content by employing Java-based logic, while the Apache Web Service server's primary purpose is to simply serve up static content such as HTML, images, audio, and text. That's what we have seen so far. We have deployed a static web applications using Apache 2 and HTTPD, but where here we are going to run a dynamic web application. For that reason, we need to have a Tomcat. Then we have RabbitMQ or MQ Rabbit. A RabbitMQ is a message broker, acts as a middleman for various services, example a web application. So they can be used to reduce loads and delivery times of web application. So servers, by delegating tasks that would normally take up a lot of time or resources to a third party that has no other job. So here messaging Message queuing allows web servers to respond to requests quickly instead of being forced to perform resource heavy procedures on the spot that may delay the response time. So message queuing is also good when you want to distribute a message to multiple consumers or to balance loads between brokers. So we have Elasticsearch. Elasticsearch, the short version is that this Elasticsearch help everyone find what they need faster, from employees who need documents from your intranet to customers browsing online for the perfect pair of shoes. But the more technical version goes a little more like the speed and scalability of Elasticsearch and its ability to index many types of content mean that it can be used for a number of use cases. Normally, it can be used for application search, website search, enterprise search, logging and log analytics, infrastructure metrics and container monitoring, application performance monitoring, geospatial data analysis and visualization, and security analytics and business analytics. It has a wide uses. Then after Elasticsearch indexing, we have a memcache. So in between we have a database, MySQL and MongoDB, but we'll go for the memcache first. So we have a memcache. Memcached is an easy to use, high performance in-memory data store. It offers a mature, scalable open source solution for delivering sub-millisecond response times, making it useful as a cache or session store. Memcached is a popular choice for powering real-time applications in web, mobile apps, gaming, ad tech, and e-commerce. Unlike databases that store data on disk or SSDs, Memcached keeps its data in memory by eliminating the need to access disks. In memory, key value stores such as Memcached avoid seek time delays and can access data in microseconds. Memcached is also distributed, meaning that is easy to scale out by adding new nodes. And since Memcached is multi-threaded, you can easily scale up compute capacity. As a result of its speed and scalability, as well as its simple design, efficient memory management, and API support for most popular languages, Memcached is a popular choice for high performance, large scale caching use cases. So then we have two. What else is left? We have MySQL and MongoDB databases. We will begin with MongoDB databases. That is, a MongoDB is a document database, is used to build highly available and scalable networks, highly available and scalable internet applications. Um, So with its flexible schema approach, it's popular with development teams using agile methodologies. So MongoDB is an open source document database built on a horizontal scale out architecture that uses a flexible schema for storing data. It was founded in 2007. MongoDB has a worldwide following in the developer community. And instead of storing data in the tables of rows or columns like a SQL databases, each record in a MongoDB database is a document described in BSON, a binary representation of the data. BSON, that's a binary representation of the data. Applications can then retrieve the information in a JSON format. Then document databases are highly flexible, allowing variations in the structure of documents and storing documents that are partially complete. So one document can have others embedded in it. So fields in a document play the role of columns in an SQL database, and like columns, they can be indexed to increase the search performance. So for indexing, we'll use Elasticsearch, and for queuing, we'll use a RabbitMQ, and for storing as a data container database, MongoDB. Then we have MySQL. So MySQL is a relational database management systems, that is RDBMS, that's RDBMS, relational database management systems, named after the founder Michael Vidonius. Its daughter, his daughter's name is My, and SQL stands for structured query. So query language. The first version of this database was released in 1995, and later on Oracle acquired the same in Jan 2010 when it was with Sun Microsystems. This database is written in C and C++ language, and it can work on different platforms like Microsoft Windows, Oracle Solaris, AX, Symbian, Linux, Mac OS, etc. So now we will see the Docker flow for the same project. So first we are going to fetch in our source code from our Git repository, and we are going to do the entire Docker workflow. Then we are going to write a Docker file for the services that need to customized. So we have Nginx, Tomcat, MySQL. So we have to write 3 Docker files in this case. We have to write 3 Docker files. Once we have written Docker file in our source code, then we are going to use a Docker build command, which will execute Docker build command, which will get executed on our Docker engine. So in our Docker file, we should have mentioned the base image. So this base image images will be pulled from Docker Hub. So Tomcat, Nginx, MySQL, these are the 3 images that we are going to pull and customize them. So Docker build command is going to read the Docker file and build our image. Once our images are ready, we are going to use a Docker Compose. The Docker Compose up. So we will mention all the containers within the images, and then we are going to test it. Once it checks out fine, then we are going to push our Docker images, then customize Docker images to Docker Hub in our own account, so that the entire Docker workflow that we are gonna do. That's what we are gonna push it to the Docker Hub using Docker push command. So to do this, we should have a basic understanding of what is a container, what is a Docker, and how it works. And you should have some hands-on experience with Docker file, how to run a Docker container, and very, very basic things of container. I hope you had it because you have been following my course for almost uh, 15, 30 to 40 videos. I hope you got the clear understanding of how to do this. So once a Docker push has been given the command, then the images will be pushed to the Docker Hub. You can see that all the images has been pushed to the Docker Hub. Then if you want to repeat the step instead of building again and again, you can just push the same images from the Docker Hub. Nginx, Tomcat, Memcached, whatever you have built it and you have pushed into the Docker Hub, the same thing can be taken back using the Docker pull command, and you can use it in your project. So now let's get into the action. So let's list down the steps that we have to follow and we have to do here. So step 1, create AWS EC2 instance. It could be T2 medium is better for this. And then step 2, looking into the setups of each service. So MySQL setup and Memcache setup, then RabbitMQ setup, then Tomcat setup. Tomcat setup is pretty important because that's application server. So Tomcat setup. And finally, Nginx setup. And step 3, we have already launched our EC2 instance with, okay, here I'm going to attach few more things. So here you should have installed Git, Docker, and Docker Hub. Sorry, Docker Compose. And so as our server is ready, and we have looked into the MySQL setup and all the services setup. Now it's time to fetch the source code. Fetch the source code of the application. Then we'll create a repositories in the Docker file. We'll create a repository in the Docker Hub. Repo in the Docker Hub. For that, we'll create organization come repository. Inside that, we'll create a repository in our Docker Hub. Then after that, let's write our Docker files. Step 5, write our Docker files for app, DB, and web. App, DB, and web. That's Nginx. Web is Nginx. App is our Tomcat. DB is our databases. So once all done, then let's build our artifact. Step 6, build artifact. Then step 7, once artifact is built, it's as usual, you can build images. Then we'll build the Docker images, and of course to build an artifact you need to install Maven. So let's install the Maven here only, and Java also is required. So Java Development Kit, JDK, both are required. Then once the images has been built, now let's run all container together. Last step, run all containers together using Docker Compose. And finally, last task of this is to validate the application, access the application in the browser, app in the browser, and validate the services. And finally, we'll close this with pushing our images to Docker Hub. That's it. This is what we are gonna do in this, and let's begin with, I have created an EC2 instance and I have installed Docker and Docker Compose. So you might have following this tutorials, Docker tutorials. So I have done this. So I will mark this. Then, so before we look into the MySQL setup, I'm gonna fetch the code, and after that we will jump into the MySQL setup. So I will fetch the source code of the application. So for that, let me get into the, so here is my source code. You can see that this is my source code. src main Java, here we have, and this is a web app. And if you get into Java and com visual account, so once resources, you see that DB backup validation and web app resources, JavaScript shield, bootstrap, images, all that are used in that, and CSS information, that's a static one, and all you can find out. Okay, this is our source code. Now, so let me create a Docker Hub. Let me create a GitHub repository for the same, so that I can push my Docker, push my repository, local repository into the GitHub, and from there I can clone it into my instance, my EC2 instance or Docker server. So here is my account. So let me go to your repositories and create a new and call it as Docker Vpro project. So I'll copy the same. I'll make it public. I will add a readme file and let me create a repository. So now let me open VS Code, new window. Let's clone the repository, clone from GitHub, remote, and it's taking some time. Yeah, Vpro, Docker Vpro project. And let me get into the T and it's imlac projects. Yeah, this is what select as a repository. So open, don't move to another window, so it's fine, absolutely. So let me close this one and let me click on source control, and before that let me get into my directory, so vprofile, and so this is what, so let me place all these things in that folder, and even Ansible compose. So this is my source code, complete source code I'm placing into this directory. So now all done. Here is my source code, a complete source code. So let me come to this, and these are the changes. Let me click on stage all the changes. I'm adding all the files into staging area. So now I'll give committing committing the source code, and click commit. So sync changes, it's syncing the changes. Let's hope it will be finished fast. Then we'll get into the GitHub and see. So main, so all done, I guess. Let's get into our repository and we'll see. Yes, this is our source code, absolutely fine. So now let me copy this so that we can clone to our GitHub, so that we can clone it to our EC2 instance. Sudo option I, clear the screen, and cd home ubuntu ls vim docker vpro. Oh, sorry. rf. So mkdir docker vpro. So cd docker vpro, and here I'm gonna clone it. So git clone and respective clone URL. So that's it. The cloning has been done. Now let me do ls. Yeah, here it is, and docker vpro project ls. This is our complete source code. So this step has been done. Now we will look into the setting up. So fetching the source code has been done. So now we will look into the setting up each of the service. So now let's look into the second step, that is that's setting up all the services, the procedure to set up all the services. That's MySQL setup, memcache, RabbitMQ, Tomcat, and Nginx. For that, let's get into that. So the first step has been done, that is setting up EC2 instance and installing the Docker Compose and Git. So now the second step is to looking at the looking at the setups of each service. How do you do that? So if you are clear about the manual procedure, then we can use that manual procedure steps as an instructions in Docker files, and based on the Docker file we can build our Docker images, then we can spin our Docker containers using Docker Compose. So that's the reason we are looking at the manual setup of each service. So there is MySQL setup document. So if we have to containerize our MySQL setup, then we should know what our steps that we have taken. So if you just need a MySQL service running with a username, database, and password, then you can directly fetch an image from Docker Hub to. So let's get into the Docker Hub and let's explore. So memcache is this. So let me click on explore and let me get the MySQL. So here is the MySQL. We can clearly see that after running MySQL service on a Linux machine, and we need, so we have different versions here. MySQL 5.8, 5, 7, 5.5, and then Debian 5.7. A lot of versions are there. So we are setting up so for the background image, the name tag, everything we can find out here. We should be very well versed with this image. So you can go through this small documentation that's provided with this, because it's an official image. So what is MySQL, how to use this image, and the commands, and various information about, and how can you use this using Docker. If you use a Docker Compose, how can you use that? You say that DB, and image information about the image, and more and more. If it is Docker Swarm, and a lot of information, and configure file, how can you attach a config file when you're building it, and a lot of environment variable, that is MySQL root password, MySQL database, MySQL user, and more and more and more. So here example of giving initializing a fresh instance. Okay, so now let's get into the, so here you can see MySQL. We definitely need to create our own image. We need to customize this setup because of username, password, and as well as we have to set up our databases. So a lot of things has to be done. So that is the reason. See, username, root user, password. So that's the reason we have to customize our database file. So MySQL, this one Docker file has to be written. Then we have memcache. So we install memcache. We have to install memcache service. We start and enable memcache service, and we run it on port 1111. It's very simple setup. I think we should be able to find an image on Docker Hub. So let's check that. So MySQL, let me get back to the Explore tab. Here it is, Explore, and here I'm gonna type. So it's taking time sometime. Yeah, memcache, memcache d, or memcache. Yeah, this is a memcache d. So there is an image memcache d. So we don't need any special customization. We just want to run the service on port 11211. So does it? So let's try to find out more information about this regarding the Docker file. So you scroll down, you can find out information about this. Okay, here just click on 1.6.18 and get into here. You will get that complete information about the Docker file of the memcache d. Okay, but anyway, yeah, here expose 11211, absolutely fine. User memcache, command memcache d, and other information. Entry point is our argument, and command is our, sorry, entry point is our command, and cmd is our command argument. Okay, so next we have RabbitMQ setup. Let's look into the RabbitMQ setup now. We have seen two setups. Now RabbitMQ. So okay, so that's good. Let's check our other service. That's RabbitMQ is quite a long setup. We have seen that's because of that dependencies. But if we have the directly a service from a container, we don't need to do all those dependencies. So this is the RabbitMQ. Let me get back. So now we are in looking at the RabbitMQ document setup. So let me type explore RabbitMQ. Yeah, RabbitMQ. So this is a RabbitMQ for us, and you can see the tags and a bit of documentation and how to run a RabbitMQ, environment variables of RabbitMQ. You can see that all, and setting up default password and username and more information. Enabling plugins and image variants also is given. Okay. So to customize Memcache, RabbitMQ, both we can. So we don't need to customize Memcache and RabbitMQ. We will use these official images directly. So then comes the hero. Now our main hero. This is where our artifact is going to build. That is Tomcat. So this is where our artifact lives, and definitely there is no question that we have to customize and create our own image for this, because a product or artifact is really going to run on this. So we won't find anyone who's giving you an image that has your application. So you have to take a Tomcat image, that is for sure. But what all customization we need, let's find out. Apart from the artifact steps are to be set up a Tomcat service. So we have to set up the repository, then we have to change the directory, then here download and Tomcat package using wget, then use unpack it, then add Tomcat user, then copy data to Tomcat home directory, and these all the steps has to be attached as instructions in Docker file. So we need to take a Tomcat image, Tomcat container, and we need to put our artifact with right back in details and application properties file. So let's check the Tomcat Docker image, official image. So Tomcat, here it is. So here you can see the Tomcat, but anyway, oh, lot of tags, lot of versions. But whatever it may be, the Tomcat has to be our, because this is application based. It is an application uh, Docker image, so that's why we have to write our own Docker image for this. So this needs to be customized. So with this MySQL database and Tomcat application and other, so Nginx, so these three things should be customized, whereas other Memcache and one more, so these things not to, we don't need to write a Docker file. So now we have Nginx. Nginx, we need to create our own image Nginx setup. We need to run the Nginx services with this configuration. So we may need, where is that? Yeah. So we need to customize that also. Total Nginx and Tomcat and MySQL. So three files we have to create, and remaining we can use official images. So three Docker files and two official images we can just pull up. So now let's move on to the step 4, that is create an organization or repository in our Docker Hub. So step 2, step 3, all done. So now it's creating an organization. So but before that, let me attach Ubuntu user as into the Docker group. So let me say user mod option A group option G to Docker, and user is Ubuntu. So that's it. Ubuntu has been added. Now let's get into our Docker Hub and let's create an organization, and let's also create a repository in that. Okay. First, let's get into the Docker Hub first. Yeah, here it is. Go up, click on organizations. We will go to repositories. Here we need three images, so we will already create a repository for it in our organization. So what we're gonna do is I will name, so we will, okay, I have an existing organization, but I'm going to create one more organization. So okay, but that's, we have to go plan free, we cannot do. So anyway, then I'm going to show, because we have to pay for that. So this is an organization I have created. In this, you can create your repositories. So in this repositories, I have created three repositories in this organization. So the organization name is vprofile charan. So what I can do is I cannot create one more organization. That's the reason I will use the same organization, and I will create three repositories, and to each repository we will push, we will publish a separate image. Okay. For now, let me create a repository. So the name of the repository here is Vpro. First one is for app, Vpro app. So repositories, so Vpro app has been created. Then next, Vpro web. Vpro web has been created. Next repository would be Vpro DB. Vpro DB. So the thing to be remembered here is vProfile is our organization name and ViproDB is the repository name. So this could be the name. This is how we have to tag. If you want to attach a tag name, that's fine. But without tag name, we are going to use it. Okay. Copy and paste it here. Some down. Additional information. I'll paste it here. That's it. So let me get back to the repositories. So these are the three repositories that we have created now. Yeah, three repositories that we have created: vprofile / vprodb, vpro web, vpro app. These three repositories we'll be using in this project. So we have done with creating an organization or repository in our Docker Hub. So now it's time to write our Docker files for app, DB, and web. So let's get into the action. So let me do ls. So here, so we have created a directory saying docker files, and inside that we are going to write our docker files. So let me get into the docker files directory and let me do ls. So we have three directories inside that. One is for app, one is for db, other one is for web. So each has their own docker files. Because why we are doing that? Because so it's a docker file. So as we have discussed, we have 5 services, out of which three services images, docker images, should be customized, whereas other two can be used official images. So that's the reason we will begin with app itself. So cd app and ls vim docker file. Yes, here. So let's go through it. From, it's a tomcat image, then labels is fine, then run. What we are doing is here remove rf whatever there is inside this web apps and copy the target, because we are going to run maven install. When you run maven install in this folder, in this present working directory, it's gonna create a target directory. Inside that we'll find vprofile v2.war. So that is going to be copied from this present working directory, and it will be placed in user local tomcat web apps root.war. So that's the reason whatever is there inside that, the default files should all be removed, and only the v profile, our artifact, should be copied into that. That's what the customization we are doing here using this docker file. So now we will expose this to 8080, and the command here is catalina.sh and then run. This is our argument, this is our command, and this is our argument. Then work there is user local tomcat, and volumes is user local tomcat web apps. So that's what is our app docker file. Let's get into db now, and vim docker file, and as usual you could see MySQL 5.7.25. That's what the base image that we are using. And then environment, we have set up MySQL root password, that's Vpro db pass, and MySQL database accounts, and add. So this is our database db backup.sql. So docker entry point and the initialization of database, and that point is also been done. Now let's get into web vim docker file. Here it is from nginx base image with the latest tag, and then rmrf remove any default config file. If you have any default config file, remove the default config from etc nginx conf.d directory, and then replace with the ngin vprofile config. Here we have our configuration, how this nginx should work as a load balancer, so that all that information we have given, we'll go through it, but first we'll do that. So etc, then place this customized config file into etc nginx conf.vprofile.conf. That's what this image do. So now let's get into our project directory. So now let's look into the cd and src ls main cd main. So here you will have your source code of our web application, and this is what is our Java application consists of. And so let's get back and do ls, and let's get into a docker file and ls. Now I am gonna show you the SQL database that we have mentioned inside the, you see that this is db backup.sql. This is the database SQL database that we have mentioned inside the docker file. Similarly, I'm going to show you the config file. So cd web ls, and this is ngin vprofile.config. Let's go through it once, and here it is. So upstream vprofile app, you can consist of vpro app, and it will be exposed at 8080, and server, it's going to listen to 80. So location proxy pass at this location, and all will be connected through this. So let me clear the screen and ls. Okay, we have seen how to create our docker file, how to customize our docker file for our application. So writing our docker files app for db app web is done. So now it's time to build our artifact using Maven JDK. So but before that we have to install Maven JDK both. So first we will begin with the JDK Java Development Kit. So I'll say, so let me do apt search JDK. So there are a lot. Let me scroll up. Java Development Kit open 8. Yeah, this is fine. Open 8 open JDK 8 JDK. Yes, this is what. So let me copy this. Scroll down. Clear the screen. Let's do installation. So apt install open JDK 8 JDK and give option wise so that it will install it without asking for your intervention. Okay, installation of Java has been done. Let me check which Java. Okay, Java version. Okay, this is what happens. Java version. Yeah, finally we got it. So Java version, it's 1.8.0 underscore 352. So now let's install Maven. Again, let's do apt search. Maven. There are a lot. We'll go with this one, the simplest one. So apt install Maven option Y. That's it. So once installation of Maven is done, now we're gonna build it. But before that, we have to look into the respective file. So let me check. Yeah, here you can find that user bin Maven. That's the Maven home. So now let me give Maven version. Yes, clear the screen. MVN version. Yes, that's it. Apache Maven 3.6.3 and Maven home is this. That's it. And here you can see the Java 8 OpenJDK also. So all done, all set. Now it's time to look into our source code and look for the properties dot. So let me. So here in main resources cd src ls cd main ls and get into the resources ls. You got the application dot properties and db backup dot sql all. So but let's look into the application dot properties. So cat application dot properties and here you can see complete information about all of our services. So where I am, yeah, here it started here. So initial one JDB driver class names and username root and then password is Vpro DB pass. This is jdbc dot username root and Vpro DB pass. And after that, this is memcached configuration for active and standby host. So memcached active host is this and port number and port and standby host is this and rabbitmq address and port and username and password. And elasticsearch configuration is this elasticsearch.host Vpro search 01, and cluster is vprofile and vprofile node. So that's okay. Let's also look into the cat validation.properties. So this is to validate, and here you can have the complete information about that also. So username, okay, additional information, size.user form and duplicate. Okay, so now it's time to build our artifact. So let's get back into our main directory. So ls, yeah, here we have our pom.xml. So here we are going to say mvn install. Once you say mvn install, it's going to build our artifact. It's going to take some time, but it's going to build our artifact. So it's taking a lot of time, but let's wait for the same for with the patience. Uh, I think we are coming to an end. This is going to build an artifact. Yeah, Jacoco has come. Maven War plugin come into the action. So that means our package is getting ready. Yes, that's correct. Build success. So let me check ls, and this is where the target directory has been created. So now let's get into the app docker file and see uh, and do vim docker file, and here you see that that's what we have mentioned. Copy and the present, go to the target and forward slash v profile v2.var and put everything in this directory. Okay, in this directory of the container or image, docker image. So that's what we have said. So v profile target from this. So target v profile dot where or so the build is successful. So let's build our images, but before we build our images, so the docker file says copy the direct copy vprofile v2.var, the artifact from target directory, and paste it in user local tomcat web apps of container. So to do that, copy we need to bring this target directory and vprofile artifact to app directory. So let's do that. So at this moment we do not have that. So what I'm gonna do is I'm gonna get back. Now you see target, so I'll copy this and I'll copy this target directory and place it into Docker files and app directory. So it's been moved. Let me cross check that. Let us get into the CD and Docker files app, and let me do ls l, it is target. Okay, ls, and so it's not been copied, so that's the reason. Let me clear the screen and I'll do it again. So cd ls copy. Okay, got it. The issue here is it's a recursive, so based on that we have to mention our target everything and put into Docker and app. So I hope it's copied. So ls l of, sorry, Docker files and app grep, it's a target. So okay, it's been done. You can see that the target artifact has been moved, has been copied to the app directory. So now all set, all done. It's time to build our first image in Vpro project. So let me directly go there, Docker files app. Yes, so we can see that we have our Docker file here. So if you want, I will cross check. Let me do the cat. Yeah, you see that this is what our Docker file. We have placed a target directory here with artifact. So all fine, all set, all done. Now it's time to build our first image in this uh, project, Vpro project. So Docker build option T, that's to tag. I'm gonna tag it as based on my Docker Hub organization. So let me get into my organization. No, leave it here. Only we have repositories. Okay, sorry, get into my organization. It's a V profile, that's the organization name, and then repositories. So this is how I have to attach V profile. So let me click, this is my app. Here is that V profile and tag name. So let me copy this exactly so that I can use it easily there. So tag and paste it, and name tag I'm gonna give version 1, that's a v1, and dot because I have this I have Docker file in this directory, and click enter. So sending build context to Docker daemon. Oh, it's a huge image, 101.1 image because it's a tomcat. So it's step 1 by 9 is done. Now step 2 by 9, project V profile name Charan. So all steps has been done. So it is successfully built and successfully tagged with V profile Charan Vipro app. But I'm not going to do with this way. So yeah, Vipro app is fine, absolutely fine. Okay. So let me check Docker images. Here is that v profile, and I'll mark it. This is with tag v1. So our first image has been built. Now let's build other two images also. So the other two images, to build other two images, let me get into the other two directories. Next we're gonna build db, the database one. So ls, you can see that Docker file and db backup.sql. So let me do the cat of Docker file so that we can see the, yes, from MySQL and environment variables. That's a root password and database. Now I'm gonna build this image. So docker build tag, and let me directly fetch it from my repositories. Vprofile db, it's here. So copy that and paste it here. Tag name I'm gonna put v1 and dot, because this is where we have our docker file. We have done cat also here. So let me execute it and let's build the docker file here. So this is a db docker file, that's a MySQL, that where we have attached the root username as well as password. You can see that account, we have set up a database, and database is an account, and we also give the password, that's Vpro db pass. That's done. Let me check docker images, and you should see vprofile share and Vpro db and Vpro app, both belongs to this project only. These are all old. Okay, so now it's time to build one more image, the final image, that is web image. That's the nginx image docker build -t that we have to give, and we have to, let's do that. But before that, we have to get into that directory first. For that, it's web, and let me give ls, and you can see that. Let's do the cat docker file, and you can clearly see that it's nginx, and then here we are replacing the default config with the customized config. If you want to see the customized config, yeah, this is our customized config. So let's build it. Docker build option T, and let's get into the Docker Hub to get the repository name. So it is web. So let me click on here and copy the repository name exactly. So you should be very careful with the name. So, and where is that? Yeah, here, and paste it after a space and change it to the version 1 v1 and dot, because that's where we have a docker file. So 5 steps from nginx, and it's gonna bring up the config files. So the config file also has been copied, so the image has been built and tagged. Let's cross check the docker images. So here it is. These are our 3 images. A customized images are ready. All right, all set, all done. We have 3 images which are customized. However, we need 2 more images, RabbitMQ and memcache. We don't need any customization on that, so we are going to simply pull them. So that image memcache d from official docker registry, and for that we will say docker pull memcache d directly, because we are not using any tag. So I'll just say docker pull memcache d with a latest tag. That's done. Now let's pull RabbitMQ. So docker pull RabbitMQ, docker pull RabbitMQ. Obviously by default it pulls a latest tag if you don't mention. So the latest tag has been pulled. So now let's do docker images. Here it is, vprofile 3 and I should memcache d and RabbitMQ. RabbitMQ is here and memcache d is here, and all 3 are customized images are also here. So now we have all the images that we need. Nginx This is Vpro Web, and MySQL, that is Vpro DB, and Tomcat, that is Vpro App, RabbitMQ, it's here, and Memcached, that's here. So all done. So we have successfully containerized, we can say, but we cannot guarantee that as long as we don't test it. So, and we are going to test it with Docker Compose. So with this, the step 7, the build Docker images also has been completed. Now we will run all containers together using Docker Compose. So it's time to test it, or it's time to run now. So for that, what we're gonna do is we will uh, create a Docker Compose. uh, so we have to install a Docker Compose first, and then after that we have to create a make directory compose, and inside that we are gonna write a docker compose.yaml file. So anyway, we have installed Docker Compose in our previous session only. So I have Docker Compose ready with me. Docker Compose version, you see that v2.15.1, or else if you want you can go through the documentation and you can easily find it's a single step. You will do just curl and a respective directory. You can install a Docker Compose in your system too. So let's get into the Compose directory where we have our Docker Compose file, and let's do vim and docker compose.yaml file. This is our Docker Compose YAML file. So at the top level file Docker Compose YAML. So first the version. At the top level we have a version. So I'm going to use version 3.8, which is mentioned in the sample Docker Compose file, but we are good with the third version, that's a 3.0. That's absolutely fine. And then from there we have mentioned the services total. How many services? 5 services. One is Vpro DB. So the first service has been identified as a Vpro DB. The second service has been identified as a Vpro Cache 01, and the third Vpro MQ01, and fourth Vpro App, and fifth is Vpro Web. So this is our first service, and the image name is vprofile Charan Vpro DB. Let me cross check the image names. So Docker images, and yeah, these are the image names. Those are fine. So let me paste it here. Yeah. So vprofile, Vpro Web, and small v version 1. Yeah, that's okay. So it's fine. Vprofile Charan Vpro DB version 1, ports 3306, mapping with 3306, and then volumes. Volume name is Vpro DB data, and var lib. This is volume mount. This is volume mount, and environment MySQL root password is Vpro DB pass. Absolutely fine. Then the second one is Vpro Cache 01. Here we are using Memcached. It's a official image that we have pulled just now, and then this is port mapping. And then we have the third service, that is Vpro MQ01. So image is RabbitMQ, and then port mapping is 15672 with the 15672, and environment variable are user and pass, which is guest and guest, same. Then finally, most important one, the hero of all services, that's Vpro App. So it's vprofile Charan Vpro App. This is our customized image that we have built, and ports are 8080 is mapped with 8080, and volumes is again a volume mount, that's Vpro App data. So there one is Vpro App DB and Vpro App data. So this is what the and that has been mapped with user local Tomcat web apps. And the final service here is Vpro Web. that is our Nginx, and this is also customized vProfile Charan web vPro web with v1 tag and port 8080. So this is our load balancer, and this is where we are going to access. Once you access Nginx server, we should able to access all other servers through it, all other services through it. So, and these are the two volumes that we have mentioned in our services. So that's why we have specifically mentioned inside the volumes object. So let's close this. Our Docker Compose file is ready. Now it's time to test. So all this seems to be good. So it's time to test it now. So let's go to the Docker engine. But before that, let me cross check. Yeah. So we have run all containers. Now it's time to run all containers together using Docker Compose. So we have Docker and we have Docker Compose also. We have just cross-checked it, but one more time I'm going to show you. So this is our Docker Compose version 2.15.1. So now let me run a Docker Compose up, and here let me cross check ls. See, this is our docker compose.ml. So now I'm gonna do docker compose up in detached mode, that's D. Let's execute. So created, started. So all has been successfully created and successfully started. The first step in this is network creation. You can see that network compose default, the network has been created by the docker compose. Then the volumes, two volumes here. One is compose vpro db data and vpro app data. So two volumes has been created and attached to the network. Then we have five containers which are composer vpro app 1, vpro web 1, vpro db 1, vpro cache 01, and vpro mq 011. So total all has been started. Now let's look into that container. So docker ps. So all five, I hope all five are running up and running, not one is in exited state. Okay, brilliant. So first one is memcache d up and running. Vprofile Charan, the second one is also running, and web is running, and db is running, rabbitmq is running. Fantastic. So now to access this, I need to access load balancer. For us Nginx is the one. So Vipro, this is what. So and port 80. So let me get into the. So this is our scheduler app. Previously we have deployed it anyway. This is that container I have removed, so it's gone. So now I'm gonna change this port number to 80, and let's see what's gonna happen. Here it is, our Vipro app. So you can click on sign up. You can give username and email ID and password and confirm password, and you can sign up to that. And then you can also log into that using admin and then admin password and click OK. So that's how our Vipro app works, and we have looked into. So run all the containers to the Docker Compose and access the app in the browser by validating the services. And the final case that we are going to do here is push our images to Docker Hub. That's what we are going to do next. Now let's push the Docker images. So Docker images, and these are my images I'm gonna push. So Docker push vprofile vpro web and version 1. So the one, so vprofile web is the first one we are pushing, and after that we'll push db, and after that we'll push app. Yeah, it's done. So then similarly we will do for DB. So the Vpro DB has been pushed. So now let's push app. So Vpro app image. So once this image has been pushed, now then we'll get into our Docker hub. So where is my Docker hub? Here, and we will look. So let me see. It's done. Is it done? So still, yes, it's done. Now let us refresh and see. And here it is. Pushed a few seconds ago, pushed a few seconds ago, pushed a few seconds ago. That's it. Your This is Wipro app, and this is Wipro DB version 1, and this is Wipro web version 1. So this is how you can push your images specifically to your organization. So let me click on to my organization. Let me get into organization, and inside my organization we can find you can find all our repositories. You see that? Let me get into my organization, web profile Charan, and here are repositories. You see that? Wipro app, Wipro DB, Wipro web. So just a minute ago it's been pushed. So with this we have successfully demonstrated the step 10, also push our images to Docker Hub. So what left? Let's bringing down all the containers together at a time by giving Docker Compose down. That's it. With this, we have successfully demonstrated Wipro app deployment. Let's summarize this one more time. So create an AWS EC2 instance and then install Git, Docker Compose, and after that we have to discuss about the MySQL setup, Memcache setup, RabbitMQ setup, Tomcat setup, Nginx setup, the manual procedure, so that we can make that activities as instructions in Docker file. Then we will fetch the source code after Docker file. Then we'll create an organization, and inside that we'll create 3 repositories in our Docker Hub. Then we'll write our Docker files for app, DB, and web, and we'll build an artifact that is Maven JDK. Then at that time we will install Maven as well as JDK. Then we'll build our Docker images. Then we'll run all containers together using Docker Compose up, and finally we will access that app in browser, and we will validate the services, and we'll push our images to the Docker Hub.